You don't want to miss out on this episode of the AI Show, where we're going to talk about Microsoft Custom Vision, Lego figures, and I have a special guest, Gerald Versluis, talking about Xamarin Forms. Hello everyone and welcome to this episode of the AI Show. In this show we will have Xamarin, Custom Vision and Lego. So hi Gerald, thanks for joining me.
Thanks for
Can
having
you
me.
introduce yourself?
Yes, my name is Gerald. I am a software engineer at the Xamarin Forms team, so I am working on making it as easy as possible for you to create awesome cross-platform solutions on iOS, Android, UWP, you name it. We write once, we run anywhere. And today we're going to see how easy it is to integrate the custom vision services with Xamarin app.
So that is cool. Thank you for joining me. And let's get started.
Okay.
So what I'm going to do is I'm going to create a model using our custom vision service. I'm going to export that model and give it to you. So our model is going to run on the device.
Yep.
Does it need an internet connection?
Nope. Well, we can. You can do different things. You can communicate through the REST APIs of the custom vision service, but we can also export the model, you know better than me, to a Core ML or TensorFlow model, and we can just run that locally on an iOS or Android device, and you do not need an internet connection for that, and it is super fast.
That is so cool. So you're saying that if I train my model here, I export it, give it to you, you can make the magic happen
On the device.
on the device,
Yes.
on an Android phone, and also on an Apple.
Yes, and even on UWP if you want to, if I'm not mistaken, the Onyx thing.
Oh yeah, that is cool. We need our Windows phones back.
Yeah.
So let's get started and build a model. To build a model, you can go to the website customvision.ai. The customvision.ai is a service from Microsoft that makes it easy to train your models. So you can do that by just uploading a few images to the service, hit the train button, and voila, you have your model. So let's do that and create a Simpsons classifier. So to get started, you have to create a new project. So we call it AI Show. You can choose between two types of projects. You can choose for a classification project or an object detection project. So the difference between those two is that if you have a classification project, it will look at the complete frame and try to guess to which class it belongs to. And if you do object detection, it will actually tell you where the object is in the image. So it can also detect multiple objects in one image. But we're going to train a basic model and choose classification. The second thing we need to choose is which classification type we are using. So there are two different ways of doing it. So you can say, hey, this is a Lego figure and it is Lisa Simpson, or you can just say, this is Lisa. We're going to do the last. The final thing we have to choose is to choose our domain. And this is like the base model that is being used to build on top of. So you can choose for food, for landmarks, retail, or a general domain. And maybe you have already noticed there is the word compact behind some of them. And if we want to export the model, you need to choose for a compact domain. So we choose general. We want to export capabilities for basic platforms, so like TensorFlow, Core ML, Onyx. So I'm creating the project now. When the project is created, I can start uploading images. So I have a lot of images from Simpsons Lego figures, and I'm going to upload them. So let's start with Bart. So I've selected the images, and now I can give it the tag Bart, and click Upload Images. I'll do that again for another figure. Let's take Ned Flanders. Select, click Open, type Ned, and click Upload. So the only thing I have to do now is hit this train button here. And voila, our model is here. And you see we have created the perfect model with a perfect score.
Of course.
But yeah, let's test it and see if it is actually working. So I click browse, go to my test images. These images were not in my training set. So I click on Ned Flanders, and we will see that it is 100% sure that it is Ned. So let's see if it can also do the same for Bart. Voila, and it is 100% sure that it is Bart. So I've created a little bit bigger model with a little bit more classes. And we're going to drill into that. I will give you some tips on how to make this model better. So first of all, we have to look at the quality of the images. So what I've done, I've created a lot of different images with the object that I want to detect in the center of the image, and I used a lot of different backgrounds. So what we don't want to happen is to create a classifier that is very good in classifying, for instance, black backgrounds. I've used the same amount of images for every class. So not like 10 for Bart and 50 for Chief Wiggum. So use always the same amount of images. So I chose 50, but for some models you will probably need a little bit more. And then I've added a negative class. That is the class where it will fall back on if it is not seeing one of these other classes. So if it sees, for instance,
Banana.
A banana, it will probably say Homer, I guess. But yeah, it will, for Family Guy maybe, it will say this is a negative, this is negative. Training this model will take a little bit longer. Let me show you how to export this model. We still see that this model is performing very well. So here I can export it and choose which flavor of AI I want. So I can go to CoreML and I can click download and I will get a zip file containing my model. There are also some, there is some sample code, there's some documentation, and basically that is for all the different types of models you can export. This is the custom vision service. So I'm going to hand it over to you, Gerald, and I want to see you use it in like a real world thing.
Let's do it.
So let's plug in the Mac, and here we are.
Here we are. Let's zoom this in a little bit. So here's the custom vision AI portal that Hank just showed you. And we have our Lego Simpsons model right here. And if we go into that, that is exactly what Hank just showed us. We can just do the export. You can do the export per iteration, I think. And you can choose between all these different platforms. So this is all pretty platform specific because CoreML is a solution for iOS, TensorFlow is a specific implementation for Android. I mean, in the end, you still classify images, that's what they do, but the APIs are very different. So if you know a little bit about Xamarin Forms, you know we try to abstract all those things away. So we try to create a layer where you can just say, okay, I want to show a button on screen, and then it will figure out how to render that button on Android and iOS. So we don't have APIs to use these kind of models yet. Maybe we will have them somewhere in the future, I don't know.
Or maybe you make them.
Maybe I will make them right after the show because I'm super excited. So right now what we have to do, I mean, you can still reach it from Xamarin Forms. We have possibilities to reach out into the platform and write some platform-specific code. And you can still use these models. So let's just do that right now. I've downloaded these models already and put them in a project that I've prepared. So let's switch over to Visual Studio for Mac that I have right here. Maybe zoom that in a little bit more. And if you've never seen a Xamarin Forms project before, or Visual Studio for Mac, which is pretty awesome that we can run Visual Studio on a Mac these days. So this here on the top would be the solution, and we have 3 projects. So we have this shared project, which is a .NET standard library, and that's where you want to write all your code if you want to share it across platforms. So basically that is where you want to have everything, including your UI definition. And then here, because at the end of the day, it's still an iOS and an Android and a UWP or macOS application, I only have Android and iOS here. So at the end of the day, you will still have an Android and an iOS binary that you have to distribute to the store. So we still need these projects, which are basically bootstrappers, to just start the app on that platform. But I have all my code right in here, and we have a main page.xaml, which has some markup code to create this UI. Let me just quickly show you so you'll have a better image of this. It's a very beautiful colored UI. I'm not the best designer, but you get the idea. So you can select a picture. I have implemented it for locally, so that will reach out to CoreML for iOS and TensorFlow for Android. And I've added a button to send the same image to the REST APIs of the custom vision. I don't think we'll cover that today, but it will all be in the sample code that we can distribute to our viewers. So we'll focus on the local one right here. And you can see this is built up from a stack layout. You can see the label for the select image, the label that will show the actual classification under here. And down here you have these two buttons. And if I were to run this on Android, it would look, well, how you would expect it on Android. But it will use all the Android native bits under the covers. So what I've done, like I mentioned, these models are pretty specific to the platform. So let's focus on iOS mostly. In my resources, I've added the model file here. So if you're watching this and you want to do this, I think it's named model.ml model when it comes from the Custom Vision API, from the Custom Vision portal. You probably want to rename it because it will generate this class for you, and it will call everything this model, and then it will start complaining about members cannot have the same name as the enclosing types and that kind of stuff. So you probably want to rename the file first before you import it here. It will generate this class for you automatically, and you basically don't need to worry about the implementation here, but it's just a helper that you can use to work with this model more easily. So the way I've implemented this, if we go to the code behind of the page that we just saw, I have a lot of code which uses a plugin to actually pick the image or take a picture with the camera. We'll see that in a little bit. And whenever we have done that, I here have a dependency service, which is one of the ways we can reach into that platform specific code from our shared code layer. And what we basically do is we register an implementation per platform. We abstract that with an interface above it. And from our shared code, we just call upon that interface. And at runtime, it will figure out, Xamarin will figure out on which platform we are running and how to resolve that interface for the actual platform-specific implementation. So that's what you see happening here. We have this dependency service resolve for our platform prediction service, is what I called it, with one method, namely classify, and that is what I provide the image stream to. So the image that I took, I put that into this interface. It will figure out at runtime where to go. And in this case, that will be the core ML service here in the iOS platform, in the iOS project. And here you can see the actual implementation of the classify. So whenever you get to here, it's still C# code, but now you will see some namespaces that are pretty specific to iOS. So you want to be familiar with a bunch of iOS APIs as well. And yeah, it will just load the image from the stream. It will scale it because the models use a pretty specific dimension for the images. So we have to, in this case, I scaled it to 224 by 224. Another method would be to crop the image, depending on what you're trying to do. That might be a better way to not have false positives or something. But in this case, I just scale it and yeah, make the image the right dimension for the models. And then I go to this model right here, which is the generated class that we just saw from the ML model. And we can just say get prediction with our input. So that will be a buffer from the image stream and an error object. That is one of the ways that Apple handles things. We have this error objects that we get data into whenever something goes wrong. But of course, nothing will go wrong today. So we get our result, and we can just look up the class label. So how did it classify this actual image? And yeah, we can also get the confidence, of course. So we can have a look at what confidence iOS has that this is the right classification. So I don't know, you can do some determination with that as well. To give the results back to our shared layer, I have created a classification result, which is a very simple object, which just has a string with a tag and a double for the confidence. But this will allow me to have another shared object that I can give back to the shared layer from my platform-specific code. So that way the shared layer will have one way of retrieving the result instead of doing that differently per platform. So yeah, I think it's time to just run this. I've ran this on the emulator just now, which I showed you, which doesn't support camera, of course. So let's just switch to my actual device right here. And we should be able to see that here in QuickTime. There we go. So now we have our image right here. And I say choose picture. I can pick one from the gallery or take one with the camera. And you can see it's hanged right here. Hello. So if we have a couple of Lego figures right here. So let's just take Krusty the Clown, which is always good. Take a picture. Use photo, it will show up here, and you can see it's instantly. It shows you Krusty 95% without any sweat. I mean, it's very fast. You don't need an internet connection. I mean, I'm connected right now, but you don't need it.
Let me try it.
Yeah.
So make sure you're not
not cheating.
No, not cheating at all. Take with camera. I'll pick Homer. Use photo. Yes, it's 89% sure. So our model.
I'm glad you picked Homer.
Yeah. So that's good. That's awesome. And it is just running on my local phone.
Yep.
So I can go to the supermarket,
Yep.
start classifying Simpsons right away.
No problem. Yes.
That's cool. So we had our custom vision service where we just uploaded some images, click the train button. We got like 5 different types of models. You pick those different types of models.
Yep.
You build a Xamarin application.
Yes.
Divided the Xamarin applications in like 2 types, one for Android, one for iOS. Did a specific implementation for that model, for that platform. Push it back to like your shared code.
Mm-hmm.
And then showed the images, the result on the screen.
Yeah. So I can quickly go to the Android one. Right here, I implemented that a little bit different, but here you can see the TensorFlow service. So that's again the platform-specific code. But you can see it implements the iPlatform prediction service. And here you can also see that same classify method. So what I chose to do here is to use a plugin for this. Which this plugin also is available from the Forms layer, basically. So you could also do this directly from the Forms shared layer, and of course that plugin holds the code to do the actual platform-specific magic. So that's basically the only thing Xamarin Forms plugins do. They just take away that need for you to do the platform-specific code yourself. Okay. But yeah, I chose to do this implementation with this plugin. And you can just say, okay, here's the image stream, classify. You get back a number of tags. You will select the first one based on the probability. And I wrap them again in my classification result and give that back to my shared code here. And then I just say description label, well, this just makes visible some label, and then set the tag and the confidence in that label. And you will see the result as we've just seen on the actual phone.
And which package did you use?
So it's actually listed right here. So it's the on-device custom vision plugin by Jim Bennett. I think he's a colleague of yours.
Exactly, yes.
Yeah.
Thank you for that, Gerald.
Sure thing.
So if they want to build this at home, where do they go?
Well, you can go to this link that is showing on screen right now somewhere. And there you'll find how to get started with a Xamarin Forms application, which is very easy. You will find how to get started with the custom vision APIs. And yeah, you will find the sample code of this right here. The sample app will have the exact model that we've just used, all the code that you've seen here. There's even some extra code to call upon the REST APIs from the actual custom vision service, so you can see also not just to do it how to do it offline, but also online. So you'll have this bunch of resources to get started today.